Continuing to do some graph analysis. Today we're going to talk more about maxes and mins, and then we're going to introduce the idea of increasing and decreasing. Those are probably really hard to see, but maybe you can at least see the end behavior. We want to review end behaviors from yesterday. It says, in general, explain the end behavior if it has an odd degree with a leading coefficient that's positive. That's the first question up here. Does anybody remember? We have not done a lot of this, so I get it if you can't remember. Why is my tablet not working? Anybody remember what odd degree meant in terms of end behaviors? Odd degree means it's doing this, okay? One end up and one end down. If it is a positive leading coefficient, then the right hand is up or the right end is up, okay? If it's a negative leading coefficient, then the left hand is up. I don't know, just right-handed people are positive. I don't know what will help you remember that. But so if it is a odd degree, the ends are going in opposite directions, and if the leading coefficient is positive, the ends are going, the left end is down, we don't know what's going on, the right end is up, okay? Can anybody tell me how you would write that as an end behavior statement? I don't care if you start with y's or x's or f of x's or... Okay, I scrunched that in there. So what is the word for this? Y approaches negative infinity. Anybody? Is that up, down, left, right? That's down. X approaches negative infinity means left. Y approaches infinity, up, and X approaches infinity, right. So it seems good, yes? Okay. What can we conclude if, in general, the graph of a polynomial function exhibits the following end behavior? So what are the words for this right here? Can anybody read that? It says x is negative infinity. That would be left. Y is negative infinity. So on the left it is down. X approaches infinity would mean right. Y approaches negative infinity would also be down. So this graph has both ends going down. What can you tell me about the polynomial? Anything? It is even polynomial. That doesn't mean the same as even function, right? That has to do with symmetry. Okay. It is an even degree is what actually it is. Even degree. Can you tell me if it's got a positive or negative leading coefficient if both ends are down? Negative leading coefficient. You got it. Okay. Do we need to practice any of that more? Anybody? Okay, because I could make up some questions to go with those graphs I put on there, but if you guys are comfortable, we'll just keep going. We can come back at the end for anybody who needs more practice. All right, so today you're going to be able to determine the zeros of a function using your graphing calculator. We've done that, right? We've done it with parabolas. Today, the graph might have like 3 zeros or even 4 zeros. It's not just a parabola. I can find the local max and min, and we're going to talk more about the fact that there can be more of those. It's that vocabulary is called locating the extrema, which I'm just going to call them maxes and mins. I can determine domain intervals where the graph is increasing or decreasing. Okay, to give you a little preview, increasing as you go left to right means up. Decreasing means the graph is going down as you go left to right. And then increasing means it's going up again. Does that sound a little bit familiar? Anybody remember doing increasing and decreasing last year? It's pretty easy either way. I need to find that spot. Okay. This is very hard to read on mine. I think I actually picked here. I filled it out already for you here. Critical points are points where the graph changes its direction or shape. Extrema are points where the graph changes direction. In other words, it was going up and then it starts coming down. There's a maximum there. If it was going down and it starts coming up, then there's a minimum there. Okay, the function has some kind of minimum or maximum value at these points. Now we're going to talk today about a little more vocabulary called a relative or absolute max or min. And there's a couple delta math questions on whether it's a relative or absolute max or min. We'll cover that in a second. A point of inflection is where the graph changes its bend or shape, but not its direction. Hi. Oh, I really don't need anything. Thank you. Yes, absolutely. Thank you, though, very, very much. Concavity, okay, is the word we're going to refer to later. That's tomorrow's lesson, but where it changes its bend or shape, or concavity. All right, everybody got the graph calculator? Oh, not quite yet. Just kidding. Gonna need it in a minute. A point where the greatest value compared to all points around it is called a local maximum, okay? The point with the greatest value over the entire domain of the function is called the absolute maximum. So this is going to be a relative, or they say it's also called a local maximum. And I just write max, guys? So do you see that this dot in the area next to it, that's a maximum, right? Can you see what I'm talking about here? Make sure you get that. And then this dot, over the course of the entire function, that's the absolute highest it hits. So that one's an absolute max. This is a relative max. So this was absolute max. And then there's the same for min. When you have an absolute min is the very, very, very bottom. It never goes below that. And a relative min is where it hit bottom because it changed direction, but it's not the very bottom of the whole graph. Now, a lot of graphs don't have an absolute max or min. Does an odd, any kind of odd graph have an absolute max or an absolute min? No, because it has arrows going up and down. Does everybody understand what I'm saying? But this would be a relative what? Max. This would be a relative min, relative max, relative min. Okay? But it doesn't, every graph doesn't have to have an absolute max or min. All right. Give the coordinates and classify the extrema for the graph of each function. Use your graphing calculator to approximate. No, we're just going to approximate from the picture because I did not give you an equation, right? Is that true in your notes? There's no equation next to these to type in? It says examples on notes, but not numbered. Is that true? Oh, these are across the bottom of the page. What page is this? 4A still? 4B, thank you. All right, so this one, what do we want? Give the coordinates and classify the extrema for each. Okay, so what is this called? This dot right down here. It is relative or absolute minimum? Absolute minimum. And if I asked you for the ordered pair, let's see, that's the origin. 1, 2, 3, 4, negative something. 5, 4, negative 5. Is anybody else getting that value? It is? Okay. So it's an absolute minimum at 4, negative 5. On delta math, it would say the minimum value of the function is negative 5 and that occurs at x equals 4. They ask for the minimum value of the function, which is the y. Okay, I just want to clarify that. All right, over here, what do we have going on here? What's this dot? That is an absolute max, and it occurs, is it like negative 1.5 and 3, or close enough? That would be an absolute max. What else are there for extrema? There's a relative max, okay, what's that point? Anybody give me that ordered pair? 1.5, negative 3? Is that what we said? Okay. And there's one more we didn't do. Yeah, there's a relative min here. Why is it not the absolute min? Because of the arrows, yep. Okay, so there's a relative min at like 0.5, negative 4-ish. We'll be able to find these exactly on the calculator, but if we just talk about them before we involve that whole calculator craziness, it helps some people who struggle with the technology. So let's just estimate. Number 3, you have on your notes, but you don't have the equation. Is that true? Okay, so can we try it on the calculator? It's negative x cubed minus 5x squared minus 3x plus 4. Should be graphing this in y equals negative x cubed minus 5x squared, negative x to the third, arrow to the right, minus 5x squared, was it minus 3 something? Minus 3x plus 4. Okay, I'm going to try Zoom 6 and start with my standard window. Is that an okay window for this graph? How do I know it's not coming back up? Somewhere on the far right or going back down on the far left. What degree was this? Was the highest exponent power? 3, okay. The highest exponent power was 3, so the most times it should cross the x-axis is 3, okay? And the end behavior should be going opposite directions because it's odd degree. Did you find it? What? Yep. Okay, so the question said to find the extrema. So we're going to find this minimum point down here and this maximum point here. Now, are either of those absolutes? No. So we have a relative min and a relative max. Can you please try to find both on your calculator and write those ordered pairs down to the nearest hundredth? Did you get it, Adriel? Okay, let me come see. Do you have a negative instead of a minus? Is it graphing now or not? Yeah, it's otherwise you have to put plus negative, but when it sees something and then a negative and then negative and then something, it doesn't know what you want it to do in between those. Like, do you need to add subtract multiply? All right, how are we doing on those ordered pairs? Second trace, I'll do minimum first, I don't know. And I like to type, I'm going to say this is somewhere out here between like -5 and -1. I got 3, -5, yes? Oh, that's a nice ordered pair, okay. Yes, -3, -5, thank you. -3, -5. And the maximum is somewhere between, I'll just start there and 1, maybe. -0.3 and 4.48. I'm not going to remember that one. Okay, so the first one was at -3, whoops, I should be writing that in the right spot. Was it -3, -5? And that was the min. And the max was at -0.33, 4.48. Anybody getting different numbers? It has to say the word max or min on your screen or you haven't gone far enough. Now, this can be a problem for students. Max and min gives people struggle. Let me just show you what happens. If I say second, we'll say max. And I go between here, everybody watching? And like I arrow to the right a little bit and I say here, it's going to find the max. It's going to say there's a max there because that's the boundaries I gave it. Do you understand what I'm saying? That any boundaries you give it, it will find the maximum value. But is that the max of the graph I'm looking for? No. So just be careful. It'll always find you a maximum value. It's just you have to choose appropriate window or you're not getting the max of the graph. All right, I did want to talk about how this would be in Delta Math real quick one more time. For the min, it would say the min of -5. Okay, the minimum value of the function, the relative min of the function is -5. And that occurs at -3. Sometimes all they ask for is the value of the function. So what is the relative max of the function? The relative max of the function is the y value up here, 4.48. If it asks of the function here, it's looking for a y value. Okay. If I go, you don't have another one anyway, right? On that page? I think we got this. Let's talk about increasing and decreasing now. Increasing and decreasing. Is this the top of the next page maybe? Yes? Okay. 5A. Increasing and decreasing refers to whether the y values are increasing or decreasing as you travel left to right. So right here it says moving from left to right. That's the huge issue for these. A function may increase or decrease or remain constant over certain intervals. And these intervals we're looking for are domain intervals or x intervals. So you're going to use x values when you tell me this is increasing coming from the left until I hit what x value? Does it stop going up here? I'm just pointing my arrow because it's coming from the left, but the function is doing this until we get to -1. Does that seem right? So how do you say coming from the left until -1? Yes. And increasing and decreasing, the intervals are always, what does that say? Oh my goodness. Half hour. I'm just going to write this. You use these kind of brackets, not square brackets when you're doing increasing or decreasing, because the bottom line is it is not increasing or decreasing at any one point. I would not count it wrong, but you don't have to worry about the square brackets, okay? Where's it constant? From what to what on this graph is it constant? From x equals -1 over 2. 1, 2, 3. Is it 4 or 5? Man, this graph paper kills me. 4? And then what is it doing? If you were tracing along, you'd be going down, okay, or decreasing, and that would happen from the x value of 4 all the way to the right to infinity. Does this seem pretty easy? Is the graph going up or down? That's all it's asking, or staying constant. And you have to give me the x's where it changes from one to the next. So, these are not on the notes, so you don't have to write them down. Can you just look up here and help me? What is happening first on this graph? Decreasing. And how do I write that? From the left of -infinity until, I don't know, I'm going to say that that's 3. I can't really see. And then what happens? From 3 to the right, it would be increasing. It's just tracing it out. Is it going up or down? Now, it feels like this is going straight, and it's not. Anything that has an asymptote is getting closer and closer, so it's either increasing or decreasing. So which is this doing as I go to the left? Decreasing. So how would I write that for the decreasing? From the left would be -infinity until, I can't tell what that is, 1, 2, 3, 4, 5, or 6. I'll go with -6. And then what is the top branch doing? Careful. It's also decreasing. Everybody see that? As you trace left to right, both of them are decreasing, because if you start at the far left, go to the right, they're both decreasing. So you would say from -6 to infinity. Usually we do that in 2, not say the whole thing is decreasing because there's a break. What about this one? If that's the whole graph, the whole thing is increasing, yes? So increasing interval would be everything. All right, do you have a couple we're going to do on this? Do you have these? Oh, the first 2 are on your notes, it says. Okay. So where do you want to start? If we start at the left, this one is doing what first? Decreasing. And because we don't know how far out that arrow goes forever, we would say it starts at -infinity. And what is the magical number we have to use called to where it stops doing that? We would have to find what? That min? Does everybody get that this is tied to what we just did? The min is where it stops decreasing. And I think it's just at 0. Does that look right? Okay, and that's the x value. The y value is -2, but you want the x values again. These are x intervals. All right, so the next section, what's the next section doing? From 0 to, I can't tell what that is. 1, 2.5, we'll say. Does that seem okay? From 0 to 2.5, it is increasing between those x values. And then it starts back down, starting at about 2.5 and going to the infinity to the right. Thank you. I appreciate that you cut those. Most excellent. Getting a little stroll in, are you? Yes. How are we doing? Decreasing, increasing, decreasing. All you do is trace it left to right. Do you have this number 9 on your on your sheet with the equation or without? Okay. So do you want to use the equation or you want to just estimate? Is everybody okay with just estimating? You could find the maxes and mins if you had to. Okay, I'm going to call this one -2. Can I just call that -2? Now, if you found it on your calculator, it would give you 1, 2, 3, 4, 5, 6, 7, something like -2, -7.3 or something crazy. But which number would you use for this? The x values, yes. This looks like about 0, 1, and this looks like about 1, -1. But remember, you're using x values only. All right, so what is it doing first? This is where students get confused, because that arrow is pointing up, right? But you read this left to right, because what you're saying is, as my x values come from the left, the y values are getting smaller and smaller. So you read it left to right. It is going down. So from the left end until -2, it's going down if we go left to right. Then it's going up between which two numbers? Come on, guys. What are the two x's there? -2 and 0. Then it goes down for a very short time between what? 0 and 1, and then from 1 on to the right forever, it is increasing. All right, I'm not going to worry. You don't have this number 10, right? And I think we have enough. This number 10, guys, in here where it's doing this little, this is called an inflection point. But it would still be decreasing from like -1 to 1. Even though it does that little bend, it's all going down. And what would I say for the first piece? What's that piece from -infinity to -1? Which? Increasing, right? Because it's going up as I go left to right. And then after it went down, it starts to do what again? Increasing again. Okay. You didn't have that one on your notes, I don't think. Okay. 6A is eventually going to be homework. Can we do number 13 together, it says? So if you go to 6A, can anybody tell me what the directions say on 6A? This worksheet is not your homework until tomorrow because you have to do inflection points too, I think. So, you know what? Let's just leave this example till tomorrow. I have some more here. No. I have some extra practice. Do we need extra practice or you got this? Anybody? I could do another something. How about we just go over this slide real fast? What is point A called on this picture? Can you see those? I like this slide. What is point A called? Yes, because the arrows, it's hard to see in my opinion. Let me try to make that a little bigger. This, because the arrows go up and down forever, A would be a relative min. What's B? Anybody know? If you read the directions, it has one we haven't talked much about yet. It's called an inflection point, okay? C, what's C? Relative max. What's D? It's not on my list, but D is a relative max. What's F? Absolute max. And what's E? Relative min, because the whole graph goes down forever. Okay, just clarifying, because I think Delta Math asked about those. Okay, your assignment's on Delta Math. I'll shut up and let you work. How's that?